Today we're beginning lesson 6.6, combining transformation of sinusoidal functions. There are three parts to this section, and the goal is to apply all transformation to graphs of sinusoidal functions. We'll achieve that by using transformation to sketch a graph. So we can look at sketching a graph the first two lessons, and the third lesson we'll be looking at writing the equation of the graph of a trigonometric function. And through these two ways, we'll be able to apply transformation to the graph of a sinusoidal function. Essentially today, we'll be beginning to use the graph of the function y is equal to a of f, open bracket b, into x minus c, close bracket, plus d, which is the image of the graph y equal to f of x after transformation. So we'll have y is equal to sine x, and this will be the transformation. Y is equal to a sine bx minus c plus d. So by the end of the first lesson, we'll be able to apply the graph of the function as a transformation. We were looking at the amplitude, which is called the vertical stretch or compression, the horizontal stretch, which is the b. In other words, how many periods there are in 360 degrees. C is your horizontal translation, so it'd be right or left, or vertical translation is your d. We'll use the algebraic way, and the amplitude is basically the maximum value minus the minimum value divided by 2. The period is 2 pi divided by b. So we'll go through each one of these section of the transformation. We have vertical shift, horizontal shift, we call phase shift, vertical shift. Midline, which is new, is halfway between the maximum and minimum values. And the equation of the midline is y equal d. So if we know d, then we know the equation of the midline. And d is the maximum value plus the minimum value divided by 2. So let's do a little bit of a recap of what we've done so far. So we look at the sine and the cosine function, and we said the sine and cosine function are periodic functions. In other words, the values of these functions repeat over a specific period. And they're described as sinusoidal function, a curve. So here's a sine function, a sine graph, and it's really derived from, we look back at the unit circle, and this would be a typical unit circle where y equals sine of x. The period is the length of the interval to which a graph repeats itself. So we start from here, and here the graph repeats itself every 2 pi. Repeats. So it's called a periodic function, something that repeats itself. And as mentioned, the amplitude is midway, is the height really from the midline. The midline is halfway between the maximum value here and the minimum. So in this case here is minimum, maximum is 1, minimum is -1, halfway, so this will be a midline, which is y is equal to 0. Which incidentally is the value of d in the transformation equation, which would be d. We will look at that in a minute. As I mentioned before, we know that this is a sine function. It's if you look at the unit circle, and we transfer the values of the unit circle to a graph, it will have this shape, what we call the sinusoidal shape. So the complete circle is 2 pi. So if you look at the first quadrant, it would be from 0 to 1 as your y value. So your x value is from 0 to pi over 2, and your y value would be your, in this case, we'll be transferring over, and that's how we end up with this sine function. The same thing would be for your cosine function. In this case, the cosine begins when, remember, cosine of 0 is 1. And cosine of pi over 2 is 0. And cosine of negative of pi is negative 1. So we have negative 1, 0 here. 1, 0, 0, 1, 0, negative 1. So I transfer, so when x is 0, y cosine is 1. So x is 0, cosine is 1. So when x is pi over 2, cosine is 0. When at pi, cosine is negative 1. And at 3 pi over 2, cosine is 0. And it's 2 pi cosine back at 1. So that's why we end up, and it repeats the cycle. If you go back to our sine, go back, sine of 0 is 0. So we have 1, 0. Remember your x value here is your sine theta, and your cos theta is your x value. So your y value is sine theta. So when x is 0, sine is 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is negative 1. And at 2 pi, sine is 0. So we're transferring using a unit circle, and that's how we ended up with this sinusoidal function. You can even visualize it as this section here, the first quadrant, would be the first part of the curve. And the second is coming down. Third is continuing downwards, and the fourth quadrant, the curve upwards. If you go back to your cosine now, because it starts from here, it's actually coming down for the first quadrant. Then it continues downwards, up, up. And then the final part is going to the maximum. So this is your maximum value. This is your minimum value. The midline is in between. The amplitude now is from your midline to your maximum value. So this is my amplitude here, which is your standard graph. Here's your amplitude is 1. Also, if you look at, so the amplitude is 1. Essentially, the radius of the circle is your amplitude. And here is, by transferring all of the values in the circle, we end up with a sine. If we look at degrees or in radians, and we say the curve is periodic, is continuous, the domain is all the real number. So the range is your maximum to your minimum, or -1. Sorry, minimum to the maximum, -1 to +1. The amplitude of the curve is the point from your midline to the maximum or midline to the minimum. And the y-intercept is only one y-intercept. So that's essentially what we've completed so far in terms of sine and cosine graph. If you look into your booklet, on page 8, I'm looking at the booklet Chapter 6, Part 2, Graphing Example Booklet. On page 8, here's some notes here. The general form of the sinusoidal function is y is equal to a sine, but also y is equal to cos a cos b into x minus c, close bracket d. So the a is your, what do you call a vertical stretch or the amplitude. So the a is your vertical stretch. And talk more about that in a minute. So a is a vertical stretch. And we'll go over each one of them in a minute, but I just want to show you from your booklet. So a, the value in the sinusoidal equation, controls a vertical stretch. If the a value is anything other than 1, the a value appears as a coefficient, right, of closer 1. If the value of a is negative, the graph is reflected. So, and we'll look at an example in a minute. So a represents the amplitude of a sinusoidal function, where a, if a is less than 0, the function reflected on the x-axis. In other words, the reflection, if it's negative. So if a is negative here, it's a reflection. We looked earlier at a sine function. And here we have our sine function. Now, this is y is equal to 1 sine x. Now, the x, or theta, is 360 degrees, or 2 pi. So it means, by standard, the theta represents 2 pi, or 360 degrees. Sine, if there's no, the a here is 1. So the amplitude is 1. So in this case here, we have a graph going up. Now, if it's negative, y is equal to negative 1 sine theta, then the graph is a reflection. So this will be your negative graph. Y is equal to negative sine x. Now, the a represents the amplitude of a sinusoidal function, and this is the formula for amplitude. And I alluded to it earlier. We said that the amplitude is your maximum minus the minimum divided by 2. So let's focus on the amplitude of this case here. So here we have the graph. And if you look at the first one here, y is equal to, this would be y going to be equal to your sine x. This one, the amplitude here is 3. This is your midline here. So we're looking at this graph here, coming up like this here. Okay. So this graph, if the amplitude would be 3, because from your midline, from here to here, so this is your maximum, which is 3, and your minimum is negative 3. So your maximum minus your minimum divided by 2, which will result in also 3. So if you were to look at this first part here, and so y is equal to 3 sine x, it means the amplitude is 3. Now, because this graph is continuous, right, it's going on forever. But in this case, we're looking at a restricted domain here. If we were to restrict the domain from 0 to 3 pi, but the arrowhead points out that the graph is continuing. And let's say this graph is continuing with the arrowhead. If it's continuing, x would be all the real numbers, because there's no restriction. The range now is from negative 3 in this case here, negative 3 to 3. And you look at your amplitude here. Now, by the way, plus 0 here would be your d. Your midline is 0. So this is your midline here, which is y is equal to 0. or D is 0. So the range is where y is between 3 and -3. Now, in the next one, it's a reflection now. This graph here, y is equal to -3x. So this should be 3 here. There's a typo there. The amplitude 2. Now, the amplitude is a positive value. It's the height or distance. The domain, x to real numbers. Now, the range now is between 2 and -2. So this is from -2 to 2. So this is the reflection, because the a value is negative. If the a is negative, it tells you that it's a reflection of the graph y equals sine x. Now, y equals sine x, if I were to do this y equals sine x, maybe it will be a graph that goes here and here. The amplitude, and if you want to continue the graph, so y is equal to sine, maybe sine x. In other words, the amplitude is 1. So here your amplitude is 1. Here your amplitude is 0.5, okay, or a half. X is a set of real numbers, and now, oops, not here. So y would be less than or equal to 5, less than or equal to 0.5, 0.5. So your amplitude is, if you look at the equation, you can identify amplitude by the value of the a. Now the period of the sinusoidal function is, you're looking at the length of one cycle. So the length of the interval of a domain over which a graph repeats itself. So we look at what the graph repeats itself. So you want to look at one cycle and look at the domain to find the length of that cycle. Now, there is a formula, period is 2 pi over b. And essentially, a period is normally a reference to how many cycles there are in a circle. So if you look at the first case, when we look back at our sine function, 2 pi, here we have 1 period because there's only 1 cycle in this entire circle. It goes wrong once. But if there are 2 cycles, say I'll go up here, come down back here. If there are 2 cycles, then we have 2 periods. Then b is what becomes 2 pi over the b now. We determine that. We take to find the b value, we take 2 pi divided by the period. So here we have the period determined from inspecting the graph by using the formula line. So let's look at this example here. Now this is our b value. So here we have our sine. We're going to look at our formula. Remember that the period, so the amplitude is our formula now. Let's go back to y is equal to a sine b into x minus c plus d. Your a is the amplitude. So here your amplitude is 1. So amplitude is 1. Your domain, now it give us a domain actually start from 0 here because there's no arrowhead. We'll leave it from, so domain is where x is greater than or equal to 0. Where x is a set of real numbers. The range, it's from -1 to 1. The period, if you look at our formula, is 2 pi over b, right? So we'll use the formula here. So the period is 2 pi over b. Now b is equal to 4. So this will be 2 pi over 4, which is half a pi. Okay, well, let's get rid of this mess here. So period is equal to 2 pi over b. So period is equal to 2 pi over 4, which is pi over 2. The next one, the amplitude is 1. Okay. The domain will be the same. X is greater or equal to 0, where x is a set of real numbers. The range is still -1 to 1. Because your midline is still 0. This is your midline here. So your amplitude is 1, so it's from minimum to maximum. The period now is 2 pi over 0.5. And if you were to look at 2 pi over 0.5, that will give us 0.5, that will 2 divided by equal 4 pi. So let's see, this is doing algebraically. Now let's look at the diagram. Remember, 2 pi is a standard. So if you look at 2 pi, which is one circle, and you want to find, let's look at, in this first graph, is sine is, we're looking at sine is 4x. So we're looking at one with a dotted line. Find, now look how many cycles they are. Now, according to this here, there should be 4 cycles. And the period should be half a pi. In other words, a complete cycle should be half a pi. So let's look what we have here. So this is our one here. So this is one cycle. Okay. And it is, yeah, it's pi over 2. That's one cycle for, and this is the function y is equal to sine 4x. Now, if you were to count the number of cycles in 2 pi, we should arrive at 4. Now, the easiest way to look at a cycle is from, if you're looking at the sine, you're looking at the midline here. So this is one cycle. Then we have 2, 3, and then 4. So we have 4 cycles. So the first one here, 1. And we have another one here, another one here. So we have 4 cycles in 2 pi. And that's how you determine a number of cycles in a period. The b refers to the number of cycles in 2 pi. And you can calculate it once if you're given the equation. Now, sometimes, as we'll see in the next section of this lesson, of this part of the lesson of this section, we'll have to sketch a graph when we're given an equation, and then the reverse of it, you're given a sketch and you have to determine the equation. So if we were just given the sketch and they ask us to say, okay, give us the equation, the first thing you want to do is look at your maximum and minimum. And that will give you your range. But also, it'll help to give you your amplitude. So because by definition, your amplitude is your maximum minus maximum value minus your minimum value divided by 2. So here, if you were to look at your amplitude, our maximum is 1, minimum is -1. So 1 minus minus 1 is 2, 2 over 2 is 1. So that's what we get amplitude of 1. So if I were to write that down, so amplitude is your maximum minus your minimum divided by 2. The period, as mentioned, is 2 pi over b. So your b is a value. If you go back to your initial equation, it's your b before. Now, we look at this equation later on to deconstruct it. So your b is after your sine. So x, the theta here, or be theta or x, represents 360 degrees or 2 pi. The c would be a horizontal shift. Right now, our standard graph for a sine begins at the origin. Now, if this graph were to shift, doesn't begin here, but shift somewhere else, we say that's the horizontal shift. We'll look at a couple of questions. But for now, let's look at this. So we have our cycle now. Let's look at the next one. You see now we have the next one with 1 sine 0.5x tells us therefore one period is 4 pi, which is the one that's on the line here. So in other words, there's for one period will stretch to 4 pi. So this here, so if it's between 0 and 1, we know there's a stretch. And here you have the stretch here. If b is greater than 1, you have a compression. So it compresses. So that's finding b. The next we look at is the phase shift, which is your horizontal shift. So now we extend the graph. We look at amplitude, we look at your horizontal compression. Now we're going to look at your horizontal shift. And here, which is our c, here we look at our standard graph. Y is equal to sine x. This is my standard graph. Well, that's the period, 2 pi is the one period. It says here a negative pi over 2. In other words, this graph shifts to the right. If it's negative, if c is negative, so negative c, horizontal shifts to the right. So the graph shifts to the right. So in other words, it's starting from here, it will shift pi over 2 units. We look at here, it's going to be 3 pi over 2, 2 pi, and that would be 2.5 pi, or 5 pi over 2. So the graph now shifts Right, so this is your shift, pi over 2 units to the right. So that's what we're looking at, this shift, right? The value of c. So let's look at a few examples here. I'll do it, and then you will try some of these on your own. So let me give you some example. Here, the value of c, there's no shift. The value of c will be 0, right? This is like minus 0 here. So value of c, though, right? So the description is there's no shift, no horizontal shift, I should say. Or phase shift, as we call it. Here we have a value of c, which is pi over 2. But because it's negative, we'll say it's translated. So we can say it's translated pi over 2 units to the right. Now, this is the value of c, which is pi over 4. It's translated pi over 4 units. Because it's positive, it's translated pi over 4 units to the left. Now, cos here to c is pi over 6. It doesn't matter if it's cos or sine. So this is translated pi over 6 units right. And the last one is pi. In other words, this graph, this cos graph, so it's translated pi units left. So as long as positive, it will go to the left. If it's negative, it was translated to the right. Now, the last section we're looking at, they call it the D. So when we're looking at your D, this is your vertical translation, so the D value. So I'll look at some other examples. So now, putting all of that equations together, all of those parts together. So we're going to sketch a graph. So this is a basic formula. Y is equal to AF BX minus C plus D. I'll post this in the blog. So here's your basic Y equals sine X graph or cos X. So we can say Y is equal to sine X or Y is equal to cos X. So from Y is equal to a sine X or Y is equal to a cos X, the translation occur here, where you may have the B changes. Right now, if I were to write this out in a translated form, the sign would be Y is equal to 1 sine, in this case, b wouldn't change, b would be the 1, it'd be x minus 0 plus 0. And you have 1 there. In other words, this tells me b is one cycle in a complete circle. Here, your amplitude is 1. Your d is your midline, is your y equals 0 or your x-axis. And there's no shift. The graph begins at the point where x is equal to 0. So vertical stretch is A. So if it's negative, we know it's reflected. Your B is a horizontal compression, so 1 over absolute value of B. Horizontal translation is your C, and your D is a vertical translation of D units. So you go up or down. And this is the formula way of finding the amplitude. The period is 2 pi over B, or 360 over B. Or if you want to find B now, it's 2 pi over the period, or 360 over the period. I also indicated your midline. Your midline is basically is your D value. Whatever your D value is will give you your midline. Okay, let's look at some other examples, and now this is from your textbook. So the graph of y equals sine x is shown below. So here is your sine x as a complete cycle. I'll just zoom in. So here's your sine. You want on the same grid sketch a graph of half sine 2x. So here we're looking at sketching our graph. Half sine 2x. So here we have our sine graph. Notice the amplitude in this case would be a half. So you're looking at half of 1. And the period would be going to be a compression now. It's pi. Okay. So remember your B, right, which is your compression by a factor of 1. So now you get 1/2, right, of what it was. So here we have a full. So now the period now is a half, or the period is 2 pi over 2, which is equal to pi. Probably easiest way to look at it to find the period. So now here we have the period. Let's see here, the amplitude is a half. So this is your, oops, I'm hiding my pi here. So now we need 4 sections. So we have 1, 2, 3, 4. So start from 0. So now remember it goes up here, 2 comes down here. Just right, here's a different color pen here. And it continues. Here we go, here, here. So you should have another cycle, and this come down. So we have here. Continues. So this is your graph because it's half, is compressed by half, by a factor of a half, or the period is pi over 2, your amplitude. Now that's where the amplitude is 1, but now we want an amplitude of a half. So we get half of that amplitude now. So now we become now this, so this is half. So if I were to redo that on a graph such as this here, if I have 0.5, 1, negative 0.5, negative 1, 2 pi is your sine function, so we have, this would be your standard graph. Y is equal to sine x. Now this continues. But this question now says, now I want to get, so we go back to our question. We have y is equal to half sine 2x. So we established that the period is equal to 2 pi over 2, which is equal to pi. So now, and now the amplitude is a half. So now instead of having it, this is my cycle, so we have it 1, 2, so now we have a complete cycle. It's 1 pi. And this will continue, but it's now, so we have two things. We have a horizontal compression and a vertical compression. So within 2 pi, we have 2 cycles. Okay, so that's the first one. The second one, here we now go one step further now. In this case where we have a horizontal shift. Okay, a horizontal shift of pi over 4. So instead of it beginning at 0.0 here now, it shifts to the right, pi over 4 units. So now it's going to be pi over 4 units now. So the same graph. So if I were to remove this one part here, this is my original sine graph. Now I'm left with so this is y is equal to, so y is equal to half sine x, so it's now right here. So we'll so y is equal to half sine x is this graph here. Now we want to change that now. We want to have a horizontal shift now of pi over 4. So now I need an equation. Y is equal to half sine 2 into x minus pi over 4. So this is pi over 4 here. So we have 3/4 pi, etc. So basically it will be the same. So now we have 1.5 pi or 3 over 2 pi. So it should be almost the exact graph, but it shifts pi over 4 unit. So instead of beginning from here, it's starting here. So I got a point here, it goes up, comes down back, goes down, and here. So this is one cycle. And you look at it, still pi is the cycle because it starts with negative pi over 4 and it ends as 3 pi over 2. And if you will continue, so this graph y is equal to half sine 2x minus pi over 4. Now the last one, now you notice what's going on here. Now we have a vertical shift 3 units down. Okay, so I can do that one right here. So now, first of all, let's establish we've already established our graph. So we now have exact everything is here except now is go down 3 units. And so starting from here, y equals 0, it's negative 3. So first of all, it shifts pi over 4 units. So here is your pi over 4. Here's the new pi. Half a pi, 3/4 pi. But instead of starting from 0 here, it's starting at this point here. So your graph is half, so it goes up. And it continues because it's a half a pi. The amplitude is a half. And it continues. So there are a few characteristics here. I just want to go over some of these here. I'll do a few of them. I'll do a couple of these here. The period here, if you look at this here, it's pi, because this period is 2 pi over 2 is equal to pi. Remember, period is 2 pi over b. The amplitude is your a value. So a here is 1. The domain, there's no restriction. We x is a set of real numbers. The range of the function is your amplitude, which is from 1 to negative 1. There's no phase shift, right? The phase shift is 0. Now the zeros, in other words, where does it cross the x-axis? So this will be continuous. If we're starting at, it will be 0. It could be like 0 plus or minus. In this case, because we have a period of pi, so every pi over 2. If you look back at the graph or original sine function, every pi over 2, right, it will be at 0 or plus or minus pi, and it goes on, right, etc. The next one here, we're looking at the period again. It's 2 pi over b, which is pi. The amplitude is there half, right? That's your A value. The domain would be same as x to the set of real numbers. Now your amplitude y is between a half and negative a half. There's no phase shift here, right? Because the graph, there's no C here. If you go back to our initial formula, your C is a phase shift. There's none here. And the 0 would be the same as here. Okay, I'll let you complete the rest here. The amplitude is half, and now I want to go into this one here. Now the amplitude is a half. Right, we can do that here. The period is 2 pi over 2, which is still pi. The domain of the function, well, there's no restrictions, so we use all the real numbers. Now the range will be an interesting one, right? Because the maximum value, so now we have a shift, right? A horizontal shift of -3. So if you were to sketch this graph, which we have it here, oops, go back to this graph here, our minimum value is 3.5, -3.5. So -3.5. And our maximum is -2.5. Or -5/2. Notice the zeros are now a quarter pi. Right, so we have here, oh, by the way, the phase shift would be pi/4, right? Sorry, if the phase shift is pi/4, see, now the zeros, there's none. Go back here, oops. Let's zoom out a little bit here. There's no zeros because the graph doesn't touch the x-axis, so there's no zeros. We said there's none because it doesn't touch the x-axis. For the next one here, which I did mention you should try that, but I'm just going to give you the result just in case you're here. The period would be the same. It would be 2 pi over 2, which is your B. It's your A. It's your C, and this is your D. So which gives you pi. The amplitude is a half. We know x is a set of real numbers. And we have the phase shift here is pi/4. The range is from a half to -1/2. But in this case here, we have our zeros. If you had gone back to our original graph, our zeros were pi/4, right, plus or minus, and we have plus or minus 3/4 pi over 4, etc. Continues. Okay, I'll just go over. By the way, we are applying. I'm just applying the transformation A, B, C, and D. One of the examples should be the last one for today. Here's your example where you're given, predict how the graph y equal to 2 sine half x minus pi over 3 minus 1 is related to the graph of y sine of x. We know our graph y equals sine of x, what it looks like. If we go back to our booklet, this is a graph y sine of x. It has two periods. The intercept are 0, pi, 2 pi. The x-intercept, only one y-intercept. The amplitude is 1. Phase shift is 0. The domain is all the real numbers, and the range is from 1 to -1. So that's our basic graph. So what I'm asking now, predict how the graph of y equal to 2 sine half x related to the graph of y sine of x. So what do we have here? For A, we have an amplitude now, a vertical stretch with the amplitude. So this is your A, your B, your C, and D. So A is your amplitude, which is 2. So you have a vertical stretch of a factor of 2. So here we're by a factor of 2. In other words, if you were to look at the standard graph of sine, this graph goes up 2 units. So it goes up to positive 2. In a moment, we'll graph this function. Next, we look at the horizontal stretch. Now, the horizontal stretch we have in this case, we'll have a horizontal stretch, right? Because the factor to remember is 1 stretch, right? It's 1 over b, right? Which is 1 over 0.5, which is equal to 2. So we have a horizontal stretch by a factor of 2, right? Because it's always 1 over absolute value of b. So 1 over b. In other words, this period, instead of being 2 pi, now it's double that. It's now 4 pi. So the period actually stretched out. So we'll look at that in a minute. Then we have C, we have horizontal. So we have our B here. So we have A is our amplitude B. Now C is our horizontal translation, right? Pi over 3 units right. So it shifts to the right. And finally, D, we have a vertical translation. Now, because it's negative, it will be 1 unit down. So that's, we have A, B, C, and D. Okay, looking at, now let's sketch that graph. The next part, sketch a graph. And then now we want to go between 0 and 4 pi. Now I should have extended this. So I have 1, 2, 3. -1, -2, -3. First of all, let's sketch a graph y equals sine. Remember y equals sine, we have y is equal to, sketch that first. No, I don't need my negative, so I can be more. I mean, I have to extend here. We have 2.5 pi, 3 pi, 3.5, 4 pi. Right there. So we have 5 pi over 2. We have 3 pi with 7 pi over 2. So first of all, let's sketch the graph of y equals sine of x. Remember, sine of x is going to give us, this is our sine of x, because it goes up here, down. Go back up here. So, oops, no. Okay, too small here. Okay, I need some more space. I grabbed. Looks kind of odd. So I need the space here. Maybe a little bit more. Okay, I make that a little too truncated.